Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today we're back here with the 20 watt Class-A amplifier. Okay, there's a playlist, by the way. If you haven't seen the previous videos, you might want to watch those. Anyway, today's video, what I want to do is this is one of the amplifier sides, and this is the side of the box. So mounts like that, right? So far what I've been doing is just kind of resting this other board on top of this side of the box, but now I've actually got it mounted there. Only by 2 bolts. It's temporary, but I got it mounted. I'm going to show you how I do that on this heatsink. Okay, so I'm going to show you how I drill and tap those holes, and let me know what I'm doing wrong or a better way to do it, because yeah, it's not my specialty for sure, but I can get by. I worked for an auto mechanic years ago when I was a kid, and I learned a little bit how to do that. So probably should have watched a YouTube video to learn better. Anyway, so I'm going to show you how I did it, okay? Not saying it's the right way, but that's one technique. The second part of the video, or primary part of the video maybe, depending on how you look at it. If you've never done that before, that might be more important to you. But the other thing what I want to do is I want to run this guy and see how hot we can get it. And, well, actually, I want to see how high a current, bias current, we can run into it, and only let it get up to about 60 C. I want to stop the temperature at 60 C. So if I can run continuously at 60 C, setting the bias current to some level, that'd be nice. Now it might have to be a really low level, so I hope not. We're going to see how high we can run it and run this continuously at 60 C. Okay, that's kind of the goal. Somewhere around 60 C. Okay, I'm going to start at, I think, 1.6 amps bias point. Okay, so I have, plus minus 30 volts roughly, and I'm going to have about 1.6 amps to start. As this thing heats up, what I've seen is after just a few minutes the current starts dropping down, because this bias transistor mounted on this heat spreader here, that little transistor, it does its function. It's supposed to cut back so you don't let the transistors go in thermal runaway. So it does its job. I've watched it over and over. It drops it pretty quick, and usually I run the test for about 15-20 minutes. I'm thinking something like that, and by then the currents drop down under an amp. Okay, so then I just let it cool off so I can run another test. Well, okay, so the last video I showed how well properly applying thermal grease to these transistors more evenly spread. Now they are much more even. The heat across them is much more even, where before it wasn't. And also the difference between the transistors and the heat spreader are a lot closer. And the heat spreader has more even temperature across it as well. Okay, so the fact I only have 2 bolts in here, no white grease between the 2 metal surfaces, it's not going to be the best case scenario. Also, with the heatsink sitting down like that, it's a heat trap, right? When it sits like this, heat rises, so it rises up to these vertical fins, and cooler air comes in, heats up, and rises up, so you get a little bit of air movement. When you're sitting down like this, it's just a heat trap. You get a hot spot down here. So, even if I can't get, I hope I can get at least an amp out, or something close to that, or above that. But if it drops down to, say, 0.8 amps, then once we get it up like this, hopefully we can get a little higher. Okay, and also once we get the top and bottom of the box, that gives us more surface area, and the front and the back of the box tied to this, which I'll use thermal paste to tie all the metal together, then the final product is where I'm going to set the final bias current. Okay, but so today's just kind of a check, kind of see where we are. All right, now when this guy was just resting on top of this, like last video, the temperature, I'm trying to think what it was like 20 or 30 degrees difference between the 2 surfaces just sitting there. Didn't mate very well thermally, so we should see way better than that with it bolted hard to it. Okay, because yeah, I can't remember what the temperature difference is right now. I have to go back and look at the other video, but it wasn't very good. I just remember that. I thought it'd be better because it's got a pretty good solid chunk of metal across the bottom, and I thought it would, and hopefully like this it's going to do as well as I think it will, but we're going to find out. So let's come over here and check that. Hey, and by the way, before we do that, I want to show you my board. All right, just real quick, I just want to show you the heat flow. We start the heat source, the transistor, goes to the spreader, then the heat sink. We got this connection, this thermal connection, really good right now, I think. We want to get it better between the heat spreader and heat sink, but we'll see where we are today. And then finally, from the heat sink to the air, okay? And that's going to be better in the when the box is sitting so the sides are vertical. Also with the, like I say, the top, bottom, the front, back connected. So those will be other surface areas that will help, you know, get heat out of them. So that brings in this surface thing here. This is my drawing of a heat sink. Yeah, it's pretty bad, huh? It's my 3D drawing. So it's 9 inches across, 4.5 inches high, and about 1 1/4 inches deep. That's how deep the fins are. So dimensions are actually a little bit bigger. I just, you know, rounded it off to a smaller dimension. And there's 22 fins, okay? So the surface area is a 1.25 inch depth times 4.5 inch high times 44, not 22, because each fin has 2 sides to it, right? So times 44 plus this 9 times 4.5, this surface area here. And I'm saying times 2 because really we have that same surface area on the other side. You know, if you're looking at the fins, you're seeing that surface, right? Yeah, I mean, some of that surface is the thickness of the fins because they're kind of wedge shaped. So it's kind of double dipping a little bit. But then again, we're not taking into account the tops and bottoms. So just roughly, we're about 328 square inches. It gives you an idea that fins really add a lot of square inches. I mean, it's really cool. That's why I use fins, okay? Now, the other thing I want to show is how much power we're going to dissipate into this chunk of metal. And it's a lot, because we have 2 volt, you know, 2 rails, plus or minus 30 volt, right around there. We'll find out when we do the power supply next video. Next video, we're going to get the power supply, and that's when a lot of these pieces are going to fall into place. I'll determine if I need to take the boards off, put different capacitors on, that kind of thing. So we got 30 volts times 1 amp. Let's just say 1 amp, make math easy. That's 30 watt, and plus it's, you know, we're hoping to go at least 1 amp or more. So that's 30 watts times 2, because there's a plus minus 30 volt rail, right? So it's 60 watts. Worst case, no music's playing, we're burning 60 watts. Now, better case, and if we're playing, you know, if you really actually were getting 20 watts average power out, like 20 watts continuous power, I should say, then it would be 60 minus 20, 40 watts. That'd be the best case scenario. But really, it's going to be 60 watts when no music's playing. So, that's a lot of heat. That maybe needs to be twice that size. So that's what I'm kind of afraid of, okay? And that's only with 1 amp, by the way. So we really want to go higher. I'm going to start off with 1.6 or 1.7. I don't know. We'll see. I forget where I have it set. So, all right, let's jump into the video and see where we are. All right, guys, so here's the deal. Here's our T1 thermocouple number 1 right here, thermocouple number 2 down here. As it gets hot, the monkey poo gets kind of soft and the leads will pull up with pressure. So I try to get them pressured so they don't want to lift, and just push them down to make sure the temperature is good. Anyway, I've been running for a while now, over a half an hour. Temperatures have stabilized, and all I've done is use 2 screws to mount it to the heatsink, which is pretty bloody hot now. And so the bias current, adjusting this pot right here, I started off about 1.4, 1.5 amps, and as it got hot and it started to get approaching 50, 60 degrees, I didn't want to go over 60. So as it approached 50, the temperature from this transistor would back off the bias current. And so I would use that pot to go just below wherever this transistor set it to try to stay ahead of it, if that makes sense. What ended up happening is, after waiting close to half an hour, it got up to just started going over 60 degrees, and I had about 1.2 amps. So I dropped it down to, well, actually it was about 1.1 at that point. So I dropped it to 1 amp and it stopped increasing in temperature, and it's been pretty stable since then. Kind of try to bunch up this heat or this thing to hold it there. Okay, so it looks pretty good right now. So I'm going to show you where the temperature is, but what I'm seeing right now is 64C on this point right here. 63C. It's kind of, like I say, it's stabilized, so it's kind of hovering just over 60 degrees. It goes from 64 again, so 63, 64 degrees. And T2 down here is like 57 degrees, right about there, 58, 57, kind of bounce around. So when I go to the T1 minus T2, right now it's about 9 degrees. And I've seen it drop as low as 5 degrees. I think when I backed off the bias current to 1 amp, then this cooled down a little bit, and the heatsink was still hot, so it got down to close to about 3 degrees at one point. Right now it's here, I'll show you, it's about 6 degrees difference between the two. So I don't have any thermal grease, and I only have 2 screws in. So we're going to get a better thermal, you know, it's going to register much better when I get a thermal paste all the way across here with 4 screws. And remember, then eventually we'll have one end of this tied to the front and one end tied to the back, and then the top and bottom pretty heavy plates mounted to the heatsink right here and here and here. So there's 3 spots to mount the tops and bottoms, and then on the sides there's 3 spots on each side. So it's going to have some more thermal interface to other metal. So I'm monitoring the current with the mixed-sig current probe. I've got a differential probe, the Pentec, and then I've got a differential probe on the output, which is the mixed-sig. Here, I'll show you the scope, what we're looking at. Well, as we scroll up here, you'll see I've got the generator sitting here, 1 kilohertz, 389 millivolts right now. So what it's giving us is the purple waveform, which turn off, that's the input, the yellow one I just turned off, that's the current, whoops. So that purple waveform there, it is 13 volts even, so it's above 20 watts, our 20 watts that we're targeting. So without clipping or anything, I've got 29.7 volts from the power supply. So that's the lowest power voltage I can go without clipping. So that's kind of where our max settings are as far as the generator, the power supply, and, you know, giving us just over 20 watts. Okay, so then I'll turn on the current. That's current waveform, and here I'll drop that down so we can 1.6 amps, almost 1.6, just below 1.5, you know, 79 or something. Okay, and that's into this 8 ohm resistive load right here. Okay, it's pretty non-inductive, pretty close. That's the Pentec differential probe. And over in this pile of mess over here, I've got all these differential probes and the current probe down here buried. Sorry about the mess. I got all these leads from another project, and I'm just trying not to tear my bench apart completely. So that is the temperature meter right there. Okay, and right now it's showing us a delta. It's 5 degrees difference between the 2 thermocouples, and that's what I kind of see. It's we're kind of see it's right above 60 degrees, about 63 right now, and T2, the heat sink, is about 58. So it took about 10-15 minutes for the heat sink to kind of start catching up to the transistors, to thermocouple number 1 on the heat spreader. But so it's, I mean, that's really hotter than what we want. 63 inside on the heat sink, that might be fine, but the heat sink itself being up to 58, that's getting pretty darn hot. And my ambient temperature in here is about 17C. So that's the absolute temperature that we're looking there. It's not the delta between room temperature and what temperature we've climbed to. That's the actual temperature on the heatsink. So you might want to add another 10 degrees with ambient temperature in your room, maybe, possibly. Hopefully not, but but yeah, I mean, you know, you could do that. I mean, it's gonna be hotter, right? right now we've been running for about 45 minutes, so it's been stable for probably, you know, a good 15 minutes. All right, guys, so I've got this one started up, and we're all ready to put the thermal paste down, put all 4 screws in, but I might want to make some changes to the board, so I'm waiting. But see, this is the way a side comes. It has mounting holes for, you know, the top, bottom, and sides, but not for the amplifier, because they don't know what amplifier you're going to put in here. So this one fits pretty nicely. Now the box is going to be pretty tight, actually. It's going to be pretty, you know, this is, you know, maybe a little bit on the small side, but it'll be a nice box, and I think it's actually going to work nice. But there you go. There's a heat spreader, big old metal piece right here. Here's the heavy parts of it. So I'm going to put them down towards the bottom of a side. Now the side is isometric. The holes are the same on both sides, so you can't really, I think it goes anyway. So I could put it this way or this way, but when I assemble it as a box, put the sides and top and bottom back on, or not the sides, but top, bottom, and front back on, then these are the sides. So when I put everything else together, I want the hot part to be at the bottom of the box, kind of, so the heavy part of the metal is right here, so it'll sink into the heat sink here, and then go up the fins, and you know, as hot air rises, it'll go up the fins and come out the top. So that's kind of the idea, is make the hot spot close to the bottom and let it spread up. Okay, as far as mounting this here, I could mount it totally square, even on both sides and top and bottom, but what I'm doing is I'm putting it slightly closer to the top, just slightly, just so that when I mount the transformer down the bottom, none of this stuff will be in the way. The transformer is going to sit at the bottom. It's going to be, let's say if the transformer is sitting down here like this, it's going to come to about that height. So I'll have clearance, and I'm going to have some distance between the transformer and the case too, but I just thought, you know, just to keep the electronics away from the transformer as much as I can, so I'm kind of pushing it towards the top, just slightly. You can see here how it's just, oh, can you see it? It's just slightly closer to the top up here. So that's kind of the idea. Okay guys, I don't know if you've seen one of these tap and drill sets before. This thing's new. I bought it just to do things like this. So what you do is, you know, if you need to thread a bolt, you can use these things. But if you need to thread a hole, first you do a starter hole with the drill bit, and then you get one of these little taps, and we're going to need number 8 for this, for the screws I'm putting in. So you take one of these guys, and then you use this little hand piece here, and you just screw it in, and it makes the threads for you in the hole. Okay, so they call that a tap and drill. Should be called drill and tap, because you drill first and then tap it. So this is just an inexpensive kit I got on Amazon. I'll put the link below if you want something like this, because it's fairly inexpensive. I'll put the price right here. Alright, this is a type I haven't used before, but I bought one of these, and it comes in a kit with all these different sizes here. And basically, what the size tells you is these are in metric, right? So you got your number 10, number 8, your basically your diameter of your bolts or your hole patterns, and then you have your thread pattern, 32. I think this is 32 threads per inch, I'm not sure, and then 24, but you got 20, 24, and 32. And 32 is kind of a common one, I think. So it comes in something like this, where you just drill, and it drills, and it has the drill bit at the end, and then it has the tap or the die, you know, set right here where it threads it all in one action. And I think if you're punching through a piece of metal, which I won't be doing, then it actually will clean the burr, because at the top of the hole you'll get kind of an uneven you know, scoring where you cut, and so this guy right here takes that burr off. So you can also get a set like this, where you have the drill bit for the particular tap that you want. So you got the tap and drill set right here, and you get these sizes. So I'll put links to all this stuff below. I tried one of these on that heatsink and it worked awesome. I started off with that first tap set I showed you, and I kind of wore out the tap. And I think the difference is, maybe it was the metal, I don't know, but I think the difference was I used this oil, and it really felt like butter. I mean, it was like butter. It just made it cutting so much easier. And so, by the way, this tap and drill set came with this tool, which is pretty nice actually. And there's the tap that I used to finish the holes in that heatsink. And it was just in the case right back here. So that's how that comes. Okay guys, so as far as mounting this, I'm just using this ruler down here, and I'm kind of, you know, just eyeballing it, trying to make sure it's pretty square and pretty close to where I want it. So I just have to go around a couple times, and yeah, that's sitting right about where I want it. So then what I'm going to do is I'm going to, now normally I have a punch, and of course, not fully moved into this house, I don't know where my tools are, all of them. So I'm going to just come down here and try to make a X so I can tell the diameter of the hole there. So I can see my etching on all 4 holes there, and I'll go ahead and I'll drill a corner one first, and then I'll make sure it's lined up for each one as I go. And you know what? Since it works on the tap, it might work on the drilling too, right? So I've just put a spot of oil on each one of these. Won't hurt, right? You guys that know more about this kind of stuff can let me know. And then you just don't want this thing to turn and move around. So what I start with is a smaller drill bit, by the way, just because it's easier to make sure you don't hunt and search or whatever they call it, and it stays place. Oh, fuck. And what often happens is you leave the drill bit in there, because I should have gone a little slower. Actually, this drill bit was kind of wore out from the last one. It actually wore out the shaft. Alright, nice new drill bit. And the key is making sure it's tight before you start drilling. And then also taking your time. Alright, so I got the 4 starter holes. And I should move all this stuff out of the way so I'm not getting sharpener everywhere. I'm going to get a vacuum and suck all this stuff up. And by the way, if you have a cloth towel that you plan to shake out, I don't advise. I advise using a paper towel that you're going to throw away, because you don't want a sharp piece of metal stuck to your cloth and then ending up inside your finger, or worse. So just checking to make sure I got them in the right spot before I finish tapping them, and they look pretty darn close. The one right here seems to be off slightly. It's kind of up. Yeah, that one right there, I would like to, when I drill the hole, try to keep the drill bit to the left side and try to, instead of hitting center, I'm going to try to come off to this side. The rest of them look lined up nice. And see, just to let you know ahead, these are the type of bolts I'm going to put in here. They are socket heads. They're cap screws. You know, they look like that. So they fit down inside these barrels. I went and bought the number 8 and number 10 to see which one fit. Should have taken the heatsink with me, right? But anyway, they're pretty inexpensive. I went to Home Depot and bought these, but I think you can buy them on Amazon too. Yeah, I forgot I had these drill bits with the die tap thing all built in one. I was going to try that, right? So I'm going to try it in one of these holes that I have all lined up. Yeah, you know, I think it works. You know, one thing that I think you have to go slow, because those tap things, as they're cutting, you know, the other thing, I forgot to put oil in it, right? I'm going to try that. Okay, I'm going to try to put the Tap Magic extra oil or whatever it's called in there. Let's try that again. You know, that oil makes all the difference. It's just weird that, you know, it works so well. Now I'm backing it out. Wow, it's amazing what difference a little oil makes. All right, let's see how that works. Wow, maybe it's good. Let me get my screwdriver. Okay, and by the way, I bought this screwdriver, Work Pro. I'll put a link for this too as well. I'm selling you all kinds of cool stuff, huh? But this guy here, you just pull down, the bits come out. They lock in real easy. But I like the way the handle holds these things, and I've got a couple of them out because I'm using them. I want to make sure they're easy to get to. I don't get them mixed up. But yeah, and then it has a ratchet setting, so you can turn this to ratchet it. So anyway, pretty cool. I just want to test it, make sure it's going to go in there. And what I recommend when you do this, and like I said, I'm not a machinist, I'm an electronics engineer, so, but you screw it in a little ways and then back it out, and it helps clean the threads and you don't get bound up. And you know what, I probably should try the oil trick on this as well, right? I mean, it feels like it's going in fine. It's just, oops, sorry, hit the tripod. But it feels like, you know, you just have to go nice and easy and slow to get them all the way in. Yeah, again, that oil makes all the difference. Holy cow. Okay, then as soon as I feel it getting stick and tightening up, I don't know if it's if I'm hitting the bottom of where I've threaded or if I just have to clean it out. So I just try it again and then back it out. I think that might be deep enough. I might have to go a little deeper, I'm not sure. One thing I can tell you is I bought these too long, okay? I bought the size 8 and the size 10 just out of a whim, thinking, well, I mean, it felt like it was close to one of those. So then you get one of these like Cool Klein tools that has these little inserts, 832s right there. So then I just, you screw it in this end. See, I got a little piece of shrapnel there. But now you don't go through this way and screw it in this side. If you do, you end up doing what I did one time, not thinking and doing that, just spacing out, I guess. Now, what I found is I go all the way in, I kind of measured it, and then I back it off a couple threads about that deep, and then I get about there, and then I just squish that thing, and it cuts it. And I've cut a few of these, and that blade might be getting dull. These are stainless steel, by the way. So there you go. And then, because the end is not nice, it's got a burr on the end now, I have to use that, and then it comes out. Okay, so then it's just fine. That's the length I want, and I think that's going to be fine. And so you can see how much I cut off. So when I bought these, instead of buying the 3/4 inch, I should have bought the 1/2 inch. By the way, there's a little bit of a burr on the top of these things when you finish. So what I do is I accidentally broke this one, but once it goes together when I snap it together. But anyway, what you do is get a larger drill bit, and it's better to have the conical ones, but this works too. And then you just put it in here, and it's like a file. And it just turns off that top of that burr. And then you just do it a few times to make it nice and smooth. Like this drill bit wants to cut in. It's like, let me have that hole. But there you go. So then it cuts off, makes it flush again. All right, I'll do the rest of these holes so you don't have to watch me, and then I'll get it ready to mount the heatsink on. All right, guys, one more trick. I started 2 screws on the ends, and this one's straight, but this one's just off a little bit. You can see down there, you can see it's off just a little bit. So what I'm going to do is, and really once you got 2 holes, I could have saved these 2 and done it with this way, but I have that starter, but I'm going to use the hole of this metal to hold my drill bit to this side, and it's going to have a little bit of a, you know, larger gap, but I think it'll still work. One thing I want to do is I want to pour a little oil in there, and I'm going to go slow so I don't snap this guy off. Now, what might have happened is it angled that way, which is fine. It's just that it's going to help me get the bolts in there when I end up. It'll help me get the bolts in there when I get ready to put it together, even if it's on an angle a little bit. I'm not a machinist, so make mistakes along the way. I just kind of learned this along the way, so give me comments below and let me know how I can do this better. That doesn't look too bad, right? I think it angled this way, which I think that's fine. It'll work, but yeah, that didn't turn out too bad. Yeah, there's my 4 holes. Okay, I'm gonna get the vacuum and clean this mess up. Hey guys, what do you think? Kind of hot, huh? Hot and sexy. Oh, heck. Hey, before we jump into this any further, I want to remember to thank my patrons, and for the new patrons, that's awesome. I really appreciate that, guys. And you become a patron for as little as $1 a month, just let you know. And or you can support the channel by using those links down below to go to Amazon and buy stuff, or you know, wherever those links take you. And anyway, so alright guys, hey, thanks for watching. I appreciate everybody watching and giving comments. Let me know what you think about what you've seen. And you know, there's some guys with a lot of knowledge out there, and I really appreciate your feedback and your tips and all that kind of stuff, your advice. And you know, I gave the area, the square inches and the heat and all that stuff, so you guys, there's probably people out there that calculate that and tell me what we can get. I know there are. I mean, there's people already made some good comments. So, but hey, next video we'll do the power supply, okay? And I think right now I'm actually kind of impressed that I could get as much as I could out of this thing. I mean, it got hot, right? But I still could get an amp and let it run continuously. I was afraid I was going to have to dial it back even further. So yeah, I'm actually kind of happy with the heatsink mounted the way it is, you know, not connected to anything, just sitting here in free space. I mean, it's got this, you know, I've got this silicone mat and a wood bench underneath it, so there's not a lot of place for this heat to go into the bench. If I had a metal bench underneath, it'd be a little different, but yeah, so right now it's looking pretty good. I got to get this thing done, so we're gonna kind of bulldoze ahead. And sorry that I'm doing so many videos just on amplifiers. I'll try to make some other stuff in, but I really need to get this thing done. So alright guys, let me know what you think, and appreciate you watching. Alright, we'll see you next time. Alright guys, so what I wanted to do is I wanted to show you how this one's used. Now I had that starter hole, so I had to drill the hole with the right size bit, okay? And then you take this guy and you make sure it's straight up and down. Put a little force on it and then just go real slow. And you screw it in. Now, as you do this, you want to be careful that you don't go too fast and that this bites, and because this is really hard brittle metal and it'll just snap. So you want to go nice and easy, and then when you feel it getting tight, then you turn it around and back it out and let the bit clean itself. Then you go down in a little bit further, and then you back it out again. And you just have to be patient. And a little oil, I think, helps a lot. Oh, fuck. And that's what happens if you go too fast. Haven't done that in a while, but there you go.